All right, sixth grade. It is math time, one of Miss Garcia's favorite time. All right, so I have created some Google Slides for each section of Unit 4, which was going to be our next unit to study here in sixth grade. So our Unit 4 is area of polygons. Poly means many, and gons means sides. So polygons are shapes or figures with many sides. Today we're going to start off real simple with 4.1. You'll see over here to the left side all the slides that I have for you. There should be 16 in all. First and foremost, you want to stay organized. If you see here, I've got a copy of my Math ISN page 130. This will be our table of contents. So, Unit 4, area of polygons. Our first couple pages, 131 through 132, is actually going to hold multiple area formulas for us, but we're just going to talk about 4.1 today. Down here in the comment section, you will see I've put a link to doodle notes. Now, these were going to be the original notes that we were going to paste into our ISN. So I encourage you, if you can access it, or if you just want to take a look at it, if you click the link here, it will take you to what I was going to print out for everybody to have. And we were going to go through it one by one. And this is just kind of a nice little visual for everybody to have. So if you can print it out, if you have a printer at home, great. You do not have to, but this would be a really great resource if you could print it and then attach it to your Math ISN. Ooh, my brain. All right. So 4.1. As always, I like to start off with what do you observe? What do you wonder? You can maybe pause the video at this moment and come up with some ideas in your head of what you observe, what you wonder about these shapes. Um, I noticed that obviously they're on a grid here, which might be helpful for us to see when talking about area. Remembering that area is the amount of space inside of a shape. So instead of perimeter that we know is the measurement of all around a shape, this section will be talking about area, which is um, the area inside of the shape. So as you continue to go, again, it gives you some more information about area, making sure that you're measuring the inside, the square measurements inside of a shape versus the perimeter, which is the outside or around a shape. So if you haven't already, which you should, but if you haven't already, please pause the video and go get your Math ISN and make sure that you have that ready to go because we are going to be putting notes into that ISN. So make sure to write it down. This should be the very next page after your table of contents. On the right-hand side, page 132, please make sure you title it 4.1 to 4.3 area formulas. You're going to section off your paper. There's going to be 6 different sections here. So, somewhere around 10 lines each. So if you count 10 lines down, draw a line, 10 lines down, draw a line, and then make sure you have one going as close to the center all the way down as you can. So this part's a little bit more review. So rectangle and square, that was 4th grade, review in 5th grade, again, review now in 6th grade. How to find the area of the shape. So of a rectangle, you would take the base, or what you might be used to hearing, the length, and multiplying it by the height, or what you might be used to hearing is width. So I've put both area formulas here. You might be used to hearing area equals length times width, but we are going to get in the habit of calling it base times height because when we get into our next unit, width will be represented in a different way. So we want to make sure that we're using some higher academic terms here. So the base you can think as base bottom. Okay, the bottom line here, and however long that measures, multiply it by however tall or the height of the rectangle, and that will give you your area in the center. How many square units can fit inside that shape. Remember, the base and the height are the 2 lengths that are connected by this little symbol here, which is your perpendicular lines, where 2 lines come together and make a perfect right angle of 90 degrees. So square is very, very similar. The only difference is that, as you know, square has 4 sides. So there's a couple ways to write that. You could say area equals side times side, which is the same as saying the base times the height here. Or you can simply say area is the side squared, which is the exact same thing as side times side. Okay, so this is your note side. Okay, and this is first a review of rectangle and square. Okay, if you flip your ISN to the left on page 131 here, please make sure you pay attention to the page numbers. I've got the page sectioned off exactly the way I have on page 132, where we're writing our notes, so we can keep those correlations between our notes and our practice. And in the same top left-hand section of the page, I've got 2 practice examples. So I've got the square here, and a square has 4 equal sides. So if each side of this square is 4 units long and 4 units tall, to find the area, you can take area is 4 squared, or in other words, area equals 4 times 4. So it would be 16 units squared. This is very important. Make sure that you include units squared, because we are counting the square units inside of the box, how many square units can fit inside. Here we have a rectangle with a base of 8 and a height of 3. You take the area formula, base times height. So area would equal 8 times 3. So area would equal 24U for units, 24 units squared. Now, if this had said 8 centimeters or 8 feet or 8 inches, we wouldn't be using the word units. We would be using that measurement of inches or feet or centimeters or whatever the measurement is. Okay. So at any time, please feel free to pause the video to catch up. I don't want you to feel like you have to keep up with my pace here, because obviously I've already have everything written down. So the next slide here has a video about finding the area of a parallelogram. I'm not going to click on it because you guys can take your time. It's a short video, but it just goes into some deeper explanation as to where the area formula comes from for a parallelogram. Okay. So here gives some more detail. The area of a polygon is the amount of surface that it covers. So you can find the area of a parallelogram in much the same way as you can find the area of a rectangle. And if anybody was able to notice that connection between a parallelogram and a rectangle, you look here at the image, a parallelogram just kind of looks like a rectangle that's been tilted on its side a little bit, like the wind pushed it a little bit too hard to one side. So again, area equals base times height. I want to bring important notice right here that the height of a parallelogram that looks like this is not this slant height here. The height, remember, as I said before, is what is connected to the base that creates this 90-degree angle. So you want to make sure that you're paying attention to the height measurement, because sometimes some problems will try and trick you there, and you're not paying attention to the slant height, but rather the actual height from the top of the shape straight down to a 90-degree angle of the bottom or the base of the shape. So if you flip your notes back to page 132, you'll see in the next box, I've provided some visuals and the formulas for the area of a parallelogram, which again, in turn, is just like the area formula of a rectangle. So you have the base on the bottom, you have the height that connects the top to the base at a 90-degree angle, and there's your area formula. I've provided this second example here, again, to show you that the height is not this slant height here, but rather the height from the top of the shape it's at a different angle here, it's from the top of the shape down to the base at this 90-degree angle. Okay. And then, as always, when you write your area answer, you want to write area equals however many units squared. Okay. Units squared. Again, how many squares you could fit inside the shape. So I've got 2 examples here, which will be shown on your practice side. So if you took, again, this would be the base, 12 meters. 14 would be the height of this parallelogram. So the area formula, 12 times 14. Now remember, we wouldn't put units squared here. We would put m for meters or meters squared. Okay. And again here for example B, 4 feet is the height, because this is just a parallelogram that's turned on its side. And the base is here 8.5 feet. So remember, as I've said all year, fractions and decimals aren't going away. So we're still going to be expected to perform different operations with decimals and fractions as well. Okay. Here gives a nice visual of how you can see a parallelogram like this with 2 units by 5 units height can look on a grid. And if you counted up the units inside and matched up the squares to the other partially shaded in squares, they would make full and complete squares. And adding all of those up, you would get 10 square units by multiplying 2 times 5. Okay. So going on to the ISN practice side, again, back to page 131. I've got these from slide 11, the parallelograms A and B, and I've copied them here to show you how we would find those areas of those two parallelograms. I also want to note that up here at the top, if you press present, everything would show up a lot bigger. So if any of you are working with a bit of a smaller screen, you can press present and it would come up bigger on whatever device that you're using. You might be able to see some of these a little bit easier. So parallelogram A, 12 meters by 14 meters. So we would multiply 12 times 14, which gives us 168 meters squared. Don't forget the meters squared. Those are your units. That tells me that you know it's area and not perimeter, because perimeter would be different. We would write the answer differently. Then we have here 8.5 feet by 4 feet. And so I take 8.5 and I multiply it by 4, and I get 34 feet squared. Okay. For this process, again, if you have access to a calculator, I don't discourage it. That is okay. But as you can see here, I've shown my steps and I've shown my work. So make sure you show that work on the page. Here is an example that the textbook shows us, base times height. Make sure you write the formula, substitute the values. The base was 12, the height was 14, and then you multiply, which gives you 168. And we write it 168 meters with the squared symbol. Okay. Now that was a really fast lesson, but please feel free to go back and rewatch it if you need to. And remember that I'm always here via Flipgrid, via email, via Instagram post or message if you have any questions. If these last two slides, so slide 15 gives you instructions on going to our big ideas through Clever. I've assigned 4.1 practice problems. As you can see down here, it's assigned as of 9 o'clock this morning, and I would like it to be done today by 9 o'clock this evening. I know some of you might have some additional responsibilities at home during this time, so I'm extending that time for today a little bit than what you're normally used to. But get on, practice finding the area of parallelograms. Again, I think this is a bit more of a review, and then make sure that you submit when you finish, and I will be checking up on those tomorrow. So if you could see here, it says problem set. There's 26 problems total, but I've only assigned you 16 of them. So please make sure that you get on and complete those assignments. Above and beyond credit, if you could take a picture of at least 2 parallelograms in or around your house, measure the base with a tape measure or a ruler if you have one. Find the perpendicular height. Remember, the height is what goes from top to bottom that creates that 90-degree angle, and record your findings in a Google Doc to share with Ms. Garcia. I will make sure to award you with some above and beyond credit for this assignment. All right. So please, again, reach out if you have any questions or need any help with anything. Make sure you stay organized with your ISN. Tomorrow we'll have more to input. So if you keep up with these lessons here, it'll be a lot easier as we go along. Okay. Have a great